Okay, so this week we're going to be going over loops, iterables, and iterators. Just want to call out and give a huge thanks to Gaurav for creating these slides for me. I'll be presenting them, but the PowerPoint and the assignments this week are going to be by Gaurav. So please do give feedback. I really like his approach to making the slides. I think he provided a lot of extra detail that I don't typically provide in my slides. So if you find that helpful, please do reach out after class and let me know what aspects you found helpful. I'll try to incorporate it into my approach to making slides, and same goes for the assignment. Yeah, thanks again to Gaurav. All right, so today we're going over loops, iterables, and iterators, and the first thing we're going to talk about is loops. So loops allow certain portions of the code to execute a number of times. This repeated execution of a set of statements is called iteration. So basically a loop allows you to iterate a number of times over some lines of code. Loops also enable iteration on Python objects that are capable of returning its members one at a time. And those are what we call iterables. So anything that you can loop over and return its members one at a time, that's an iterable object. So we have a couple different types of loops. There are for loops and while loops. And then, of course, we can nest loops. Like we've talked about in previous lectures, like with conditionals, you can nest loops as well. And then you can, of course, nest like conditionals and such inside of loops as well. And as mentioned, iterable objects are objects that you can, iterate over and return its members one at a time. Some iterable objects are arrays and lists, dictionaries, tuples, and strings. Yeah, and then you can also create some of your own iterable objects as well. So common functions that are used to loop is the range function. Basically, the range function will allow us to loop over in a defined range of numbers, basically, and you can kind of play around with how that range works. But it's kind of like, if you want to execute a loop a defined number of times, oftentimes you're going to use the range function. So keep that in mind. All right, so first we're going to start with a for loop. So with a for loop, we can iterate in a number of different ways, but in this example, we're iterating a list object using a for loop. So here we defined our list. So this is a student names list. We have David, John, Simon, and Jack in our list here. And then in our for loop, we can loop over that list. And so what we have here is we have for, which is our keyword here. Then we have a student name, which is basically a reference to the object inside of the list. So we're saying you can kind of think of it like for each student name in student names list. Of course, you don't include the each here, as you can tell, but that's often an intuitive way to think about how this works. So we say for student name in student names list, kind of in our mind thinking for each student name in student names list. Then we do something inside of our for loop with the student name. So we're almost always going to want to reference the value that we gave here in our for statement inside of our for loop somehow. In this case, what we're going to do is we're just going to print out the student name. Remember that every time you do a print, it kind of prints it on its own line. So when we execute this loop, it'll print all the items in the student names list one by one. So it'll print out David, John, Simon, and Jack all on their own line, because that's the statement that we have here, is just to print that out. But if we wanted to do anything else with it, we certainly could. We could have situations where, say, we have, we wanted to say like hello to each student. So you could say, in this print statement, we could have hello student name, or say we wanted to alter the student name somehow. We wanted to append something to the end of each student name. We could do that operation inside the loop here. Some important syntactical things to know about loops. They're always going to end with this colon here. So keep that in mind. You have your for statement up here. And remember, we can kind of think of this as like for each student name in student names list. and then we have our colon at the end, and then the set of code that you want to execute under or within that loop each iteration of that loop goes indented underneath your for statement. So remember, indentation is very important in Python. All right, and just something to note, this name here, it doesn't have any specific requirements. You can give it any particular name you want. So we could have said for X in student names list and then done print X here. You just often want it to be something something useful and informative. So in this case, since it's a student names list, we just say for student name in student names list, and then we print out the student name. But yeah, this doesn't have any particular requirements, and you can kind of think of it as like as a variable where on each iteration of the loop. So like the first iteration of the loop, this variable has the its value is assigned the first value in our list. Second iteration, the second value. Third iteration, third value, and so on. All right. So for loops continued, strings are arrays of bytes. Remember last week when we talked about the relationship between strings and lists. So we can kind of think of strings as an array of bytes. So we can iterate a string using a loop. So in this particular case, we're going to initialize our string. We have our welcome message string. We set that equal to hello to everyone. And then we have for message char in welcome message string. So it's like for each message char or character, you'll often hear char in exchange for a character. It's just an abbreviation. It comes from other programming languages where they're actually called an individual character is called a char, whereas a whole word or collection of characters is a string. So for message char in welcome message string, print message char. So basically what we're saying is for each character in that string, print that character. And remember, the print statement prints on its own line. So when we execute that, it'll iterate that that string object and print every character, including the spaces, each on a new line. So we have our spaces here. So we have HELLO space TO space, and you'll notice it is in order because strings have a defined order, and it prints them all on their own line here. So it's often useful to iterate a string, or say you have like a number where you need to do something with each digit in that number. You can cast that to a string and then iterate over that string and do whatever you need with the characters or the digits inside that string. Okay. Any questions on for loops before I move on to while loops? All right. So for while loops, a while loop is used to execute a set of statements or iterate an object until the condition in the while statement is true. So while statements are different in that they just have while condition. So you can kind of think of it as while our condition is true, do whatever goes inside the code block there. Again, it'll end in a colon, and the code that you want to execute is indented underneath the while there. So the condition here must be evaluated as true or false. So we want a Boolean expression in the condition there. So just like in an if statement, you have a Boolean expression go there. You would want some sort of Boolean expression to go here, and then any code. Basically, eventually, you want the any code to have some operation that will eventually turn the condition to false. There are some ways to get around this, and we'll talk about that later on. Because there's a concept in programming that it exists in many other languages called a do-while loop, and a do-while loop is like a while loop, but you always make sure to evaluate the code at least once, because there are cases where say if someone made index equal to 5 here, this while loop would never execute the contents of it, but there are cases where you want to make sure that the code inside the while loop executes at least once, and then goes on from there, and we'll talk about that a little later on. But for the time being, just make sure that your condition can always evaluate to false at some point. So again, you have your while loop, your while keyword, the condition, colon, and then tabbed underneath or indented underneath, you have any code and some operation that eventually turns the condition to false. So remember, this is very important. Otherwise, the code will not stop and you'll end up in an infinite loop. Infinite loops are very dangerous for a number of reasons. They can end up crashing your program or your computer, especially if you have resource-intensive operations happening in there and something where you're just like constantly adding something up or expanding the size of an object. Eventually, you can run out of memory if you have a runaway loop in an infinite loop. So in this particular case, we're going to create a fruits list. And in our fruits list, we have apple, grapes, bananas, oranges. We start out with index equal to 0. So this is kind of initializing our counter variable, you can think of it. And then we have while index is less than 4. So this is our Boolean expression or our condition in this case. And then our colon to follow it up. And then indented underneath that, we have print fruits at index. So remember how we index or reference individual elements inside of a list. We use our square bracket notation here, and then we put the index value in there. So since our index value in this particular case is a integer, so on the first iteration of this loop, we print that fruits at index, so that'll print the value at index 0. And then what we want to do is we have to have our operation that eventually turns the condition up here to false. So we call this our condition manipulator. So then we set index equal to index plus 1. Another way you could have done this is index plus equals 1, just to make sure that on each iteration of the loop, index will increase by 1, so that eventually index will be greater than or equal to 4, and will never and this will evaluate to false. Once this evaluates to false, then we would execute the lines of code down here. So note, while requires index to iterate through the members of the object, while for doesn't. So if you're trying to iterate through an iterable and you want to iterate over the members of an iterable object like a list, you would need to use an index for doing that. Whereas with the for loop, as we saw previously, you can just have for like each. It's basically like for each element in that iterable object. But sometimes there are cases where you don't have an iterable object to iterate over. You just want to execute something until you can get some certain true condition, and that's where you would prefer to use a while loop. This particular case, you'd maybe opt for a for loop because it's more intuitive. But for the sake of example, you can switch any code between a for loop and a while loop. Any questions on this slide? All right.
Hi, David. It's Hugo over here. Can you please explain the note down? The note down.
The which one? Sorry.
The note while require index to iterate through the members.
Yeah. So a while requires an index to iterate through the members of an object, while a for loop doesn't. So notice here that in order to iterate over these objects in here, we had to have this index variable, and then we're referencing fruits at index using our bracket notation here. So this is the only way that we can access each individual item in here, is using this index value and indexing our list here. So we have to explicitly index the list here, and then if we execute this loop, it'll print kind of similarly to what we had here. Instead of David, John, Simon, Jack, this loop would print apple, grapes, bananas, oranges, all on a separate line, but we have to index our list here. So we have to reference, we have to use our index variable to grab the value at a particular index in our list. Whereas if we go back to the for loop here, we never had to index. So see, like we're never taking student names list and putting the bracket notation after it and referencing like student names list at index 0 or anything like that. We don't need to do that to get David. In this particular case, we have for student name in student names list. So on the first iteration of the loop, we're looking at the first name on that list, which is David, the second iteration, John, the third iteration, Simon, and the fourth iteration, Jack. Whereas in this loop, because index is 0 on the first iteration, so we enter our loop, we have print fruits at index 0, so we print apple. Then we increment index by 1. So on our second iteration of the loop, now we come in, index is now 2, or is now 1, sorry. Index is now 1. 1 is still less than 4. So we print fruits at index 1, which will output grapes. Then we increment index again. Now index has the value 2. 2 is still less than 4, so we enter our loop. We have fruits at index 2 using our bracket notation and indexing our list. Then we get bananas back. We increment index once more, come back up here, evaluate our condition again. The condition still evaluates to true because index is now 3. So we get fruits at index 3, which will output oranges. Then we increment index again. And now we come up here, evaluate our condition again. Index is now 4. 4 is not less than 4. So this evaluates to false. So we do not enter the loop again, and we would go on to whatever code follows our loop. But we had to use this index variable for getting the individual elements inside of our fruits list, whereas with the for loop here, we didn't have to do that. We never actually indexed the list. Does that help clarify that a little bit?
Yeah, thank you very much.
Awesome. No problem at all.
So sorry, if you run that program, it will give you, can you go back to the second slide, please? So if you run this program, yes, it would give you apple, grape, bananas, and orange, all 4.
Correct. Yeah, exactly. So this would output apple, grapes, bananas, and oranges.
Okay.
Yeah.
All right. Thanks, David.
Yeah, of course. Yeah, and we just had to use the index here, whereas, we could convert this to a for loop. So we could say like for fruit in fruits, and then we would just have to print fruit instead of, printing fruits at index. So, great question. Thank you for the question. Anyone else have any questions? All right, thanks. Okay, so nested loops. So it is possible to nest loops. As mentioned at the beginning of this, it's just like nesting. It's just like nesting an if statement or a conditional. In here, you can nest loops as well. So you can have a for loop inside of another for loop, or a while loop inside of another while loop. Or in this particular case, we have a for loop inside of a while loop. You could also have a while loop inside of a for loop. You can nest them however you want, and they can nest basically indefinitely. Just be very careful with nesting indefinitely. That's when you're really going to encounter, even if you do have a condition where eventually you will, your while loop will eventually evaluate to false, and eventually you'll get out of the loop. Just be careful with nesting loops because you can quickly get to a situation where you use up all your memory. So in this particular case, we have our row count. We're setting it equal to 1 at first. And then in our while loop, we have it's our outer while loop. We check while row count is less than or equal to 6. So in our first iteration, row count is 1. So we print row and then the row count. So we're going to get like row 1 on our first iteration of the loop. And then we do for star in range 0 row count. So this is our first use of the range function. Basically, you have range start at. The arguments to range are you have like a value to start at, and then you have a value to go up to exclusive. We'll talk more about that in a bit. And then in this case, so we have for star in range. Then we print star, and that's kind of going to return the numbers basically. So star will be a number here, so it would be 0 to 1. So we start at 0, it would print 0, and then since row count is exclusive, it would only print 0 the first time. Then we increment row count here, so that eventually our while loop will evaluate to false. But you can see here that this is our inside for loop, which is nested inside of our while loop. Again, we've got all of our necessary syntax here with our colon, then indenting everything here, and then with our for loop, we end it with a colon again, and then we indent what we want to execute under that for loop. We indent that into the for loop. And then notice this here, it's outside of the for loop. It's not indented under the for loop. So this line of code executes really as part of the while loop. It won't execute the number of times that the for loop executes, only the number of times that the while loop executes. So when we run this, we get this output. So we have row 1. So first iteration of the loop, row count is 1. So while row count is less than or equal to 6, so 1 is less than or equal to 6. So we go into the loop, we print row and then the row count. So we have row 1, and then for star in range 0 to row count. Remember, row count will be exclusive, so we start at 0, go up to row count, but don't use row count. So this basically returns just a list with only the value 0 in it. Then we print star, so we're printing 0 here. Then we exit out of that because range only returns, up to row count, but it's exclusive to this second argument here. So we only print 0. We come out to here, we increment row count. So row count equals row count plus 1. So now the value of row count is 2. So we come up to our while loop. While row count is less than or equal to 6. So row count currently contains the value 2. So 2 is less than or equal to 6. So we enter into this while loop here. We print row 2, and then for star in range 0 to 2. So remember, this is exclusive, but we go up to it. So this would return 0 and 1. So then we print 0, and on our first iteration of the for loop, and then our second iteration of the for loop, we print 1. Now again, we come out here. So because we've iterated over everything in range 0 to 2, then we increment row count. Row count is now 3. 3 is less than or equal to 6. So we come into here, we print row 3, which we see right there. Then for star in range 0 to 3, again, 3 is exclusive. So we'll have 0, 1, and 2 as the list that's returned by this range function. Then we iterate over that list. And we print out 0 on our first iteration of the for loop, 1 on our second iteration of the for loop, and 2 on the third iteration of the for loop. Now we've exhausted the range of numbers returned by range, so we exit that for loop, and then we increment row count again. So now row count has the value 4. 4 is less than or equal to 6. We print row 4. Come in here for star in range 0 to 4, again exclusive. So this is going to return a range of numbers 0, 1, 2, and 3. So we'll iterate over those. We print each of those over here, and then we increment again, and this just keeps going on until eventually we get to a point where now row count is equal to 6. So row count is 6. So 6 is less than or equal to 6. So that evaluates to true. We print row 6, come in here for star in range 0, 6. That returns a range of numbers 0 through 6. So we have 0, 1, 2, 3, 4, 5, or 0 up to 6, sorry, not through. So it's exclusive again. So then we iterate over that range of numbers, and we print each of those numbers one at a time. So on the first iteration of that for loop, 0, second, we print 1, third, 2, fourth, 3, fifth, 4, and then sixth, 5. Then we are going to increment row count again. So row count was 6, now it's 7. Come back up here, evaluate, is 7 less than or equal to 6? It's not, so we exit our loop, and this is the only output we get here. And now our nested loops are done executing. So nested loops can be quite complicated to understand and read through. Any questions on that before I move on to the next slide? All right. So iterable functions. So range is an example of an iterable function. So range, it returns a set of numbers. The syntax is range, start, stop, and step. Start is an optional argument. So if you leave it out, it'll just start at 0, basically. Stop is a mandatory argument. So if you only enter a single value into range here, that's going to be what your stop value is. And then step is again optional, and it defaults to 1. So start is optional, it defaults to 0. Stop is mandatory, so regardless you have to specify it. And then step is optional, and it defaults to 1. So in this case here, for this loop, we have for I in range 5. Remember, the stop is exclusive, so we won't see 5 printed here when we iterate over all the values returned by range. So we just print out 0, 1, 2, 3, 4 in this particular case. Here we're going to leverage the start and stop. So in this case, we have for I in range 1 to 4. we want to start at 1. We don't want to start at 0. So so when we print this, then we just get 1, 2, and 3, because remember the 4 is still exclusive there. And then say for some reason we don't want to we don't want to do every number. Say we just want to do odd numbers here. This is a way that we could do it in this for loop down here. We have for I in range, start at 1, go up to 8 exclusive. So 8 won't actually be evaluated there. And we use a step of 2. So using that step of 2 means that on the first iteration of the loop, we have 1 because that's what we start at. We print 1. Second iteration of the loop, we increment the value basically by 2. So because of the step that we passed here, so now we're going to get 3 on the second iteration of the loop. The third iteration of the loop, we increment our value by 2 again, and we end up with 5 because we're using a step of 2. And then our next iteration, we get 7 because we're incrementing by 2. So this basically outputs just all odd numbers between 1 and 8. Any questions on the range function so far? All right, great. So iterable functions continued. Similarly, there are .keys, .values, .iterkeys, .items for iterating dictionaries. So in the past, when we went over dictionaries, recall that there are these methods that we can call on our dictionaries. So you have a dictionary and you can call the .keys method on it, or the .values method, or the .iterkeys, or the .items method. So if we have a dictionary and we call the keys method on that dictionary, this would return an iterable list essentially of all the keys in the dictionary. So say we just wanted to loop over all of the keys in our dictionary, we could do that using the keys method. So maybe you'd have like for key in my dictionary .keys, and then you would iterate over that. And I'll show an example of that. Same goes for values, and then same goes for items as well. When with items, there's actually a special way you can do this here, because remember, if you recall, items returns a tuple. So it'll return a tuple where the first value in each, or a list of tuples. So the first value in each tuple is a key, and then the second value in each tuple is a value. And there's a special way that we can access both of those values in our loop, which I'll show at in the demo at the end of class. So then there's enumerate to convert a list into an iterable list of tuples, or iter to iterate through lists, arrays, strings, etc., and many more. So you can use a lot of these. You're not always going to see them, but just know that you can use them. The ones you'll use most often are the keys method, values methods, and items methods on your dictionary. And I'll show examples of those at the end of class, but are there any questions on them right now? Great. Okay, so the break statement. Break statement is very important to know because you can break out of a loop at some point if you want to. So a break statement in Python terminates the current loop and resumes execution at the next statement. So basically what it does is it breaks you out of your loop. That's a good way to think about it. And it just stops execution of the loop and exits the loop. So here we're defining a list, orange, banana, toys, grapes. We're then going to loop through the items in that list. So our list is called items. So for item in items, if toys is equal to item, so that we're basically looking for the toys item in our dictionary. Then we would print I found toys in list of fruits, breaking, and then we break. So this break will then exit us out of the loop. We won't see this line of code executed, and we won't go to the next iteration of our loop if there's another iteration after that break, and we would just come to the I am out of the loop line here. So in this case, we start in here. So we have items. It's orange, banana, toys, grapes. And then for item in items, if toys is equal to item, then we print that. So first iteration of the loop, item is equal to orange. So on our first iteration, item is orange. So if toys is equal to orange in this case, it's not. So this evaluates to false. So we never execute the line of code inside of this if statement, remembering back to conditionals here. So instead we just go down here and we just print inside loop, and then we output the item. So you'll have inside loop orange here. And then we come back to our next iteration of the loop. Now our item is banana because we're on the second iteration of our loop. So we're getting the second item. So item is equal to banana now. We check if toys is equal to item. It's not because item is banana. So toys does not equal item. So this evaluates to false. The code inside here never executes. And then we come down here, print inside loop item. So that prints inside loop banana because our item was banana in that case. So now third iteration of the loop, item is now equal to toys. So we enter our loop here. If toys is equal to item, it is because our item is toys in our third iteration of the loop. So this evaluates to true. So we go to the code that executes inside of that if statement. So then we would print, I found toys in list of fruits, breaking, and then we break. Because we break here, we never execute this line of code now, and we just come to the outside of the loop because we're done looping. We broke out of our for loop, and then we print I'm out of the loop. So on that third iteration, if toys is equal to item, it is. This evaluates to true. We print I found toys in the list of fruits, breaking, and then we're going to see our print statement for I am out of loop. So it exited the loop at that point because we executed that break statement. So break statements are extremely useful. This is one way that you can ensure that you don't get an infinite loop. There's a way that there's a way that you can this is a way that you can exit, say, a while loop that has like an infinite loop going on. So like it is possible to create a while loop where you just have while true. So that just always executes. That'll always evaluate to true. But a way you can exit that loop is using a break statement. So if you have like while true and then there's some condition that you want to evaluate inside the loop because it's not deterministic about how you can get to that condition, so you didn't want to include it in the condition block of your while loop, then you can use that to break out of your while loop. And I'll show an example of that at the end of class. Any questions on the break statement? All right. So the continue statement. Continue statement in Python is used to skip the rest of the code inside a loop only for the current iteration. The loop doesn't terminate, but continues to the next iteration. So now we basically have our same loop here, but instead of break, we're gonna use continue. So in this case, we'll wanna notice how it did not print inside loop toys, but it did print inside loop grapes before exiting from the loop. So now we have this same list, orange, banana, toys, grapes. So first iteration, it's orange. This item is equal to orange. So this evaluates to false. We don't print anything there. So we come down to here, inside loop, orange. Then second iteration, item is banana. So if toys is equal to item, it's not because this is basically checking toys equals banana. That evaluates to false. So we come down here, inside loop, banana. Third iteration, item is toys. If toys is equal to item, it is because this is essentially toys equals toys. That evaluates to true. So we print, I found toys in list of fruits, continuing, and then we continue. Because we continue, so we see that print here, I found toys in list of fruits, continuing. So we continue, and we never see this inside loop toys print out here because we continue to the next iteration of the loop. We skip everything that remains in the for loop, and we continue to the next iteration. And then our next iteration, now item is equal to grapes. If toys is equal to item, it's not because this is like toys equal grapes. So that evaluates to false. We print this statement here, print inside loop items, we inside loop grapes, and then we exit the loop because we've reached the end of our list and we only iterated each item in that list. So then we're out of the loop here. Questions on the continue statement? Continue and break are both extremely valuable. Basically, continue is when you don't want to evaluate the following lines in your loop, but you want to continue executing the loop. But whereas break is how you execute or exit your loop. So you want to just be done with your loop execution. You don't want to evaluate the rest of the items that you're iterating over, and you want to exit the loop. Questions on those? All right. So additional resources from W3 schools here. We have for loops and while loops. Highly, highly, highly recommend checking these out. Loops are one of the more complicated things that you'll learn in introduction computer science or introduction programming. So this is going to be kind of difficult your first times around. There you'll probably encounter a number of issues, but please do check out these resources if you struggle at all. Check out these resources, rewatch the lecture, and there are exercises at the bottom of the page that are pretty helpful with guiding you toward a solution and a better understanding of for loops and while loops. But please do check these out. Loops are very complicated to wrap your head around the first times. They seem kind of simple when you first see them, but there is a lot of complexity with them. Cool. So let's exit out of this. Any questions on the slides before I start reviewing the assignment for the week? All right. So the assignment this week, again, thanks to Gaurav for taking the time to write this up. So we have 3 questions in our assignment here. So we want to write a program that accepts a number and outputs valid if it is 5 numbers long. So there's a couple ways that you can go about doing this, but please try to use this with a loop. So we have example 1, x equals 1, 2, 3, 4. The answer here, it would output invalid. So we want basically the loop that you put in here to print out invalid for this particular number. And then for example 2, we have x equals 4, 5, 3, 2, 1. So this does have 5 numbers in it. So this should print out that it is a valid number for processing. So valid for processing. And please use a loop to do this. So question 2, modify the program in question 1 that adds all the digits of the entered number and display it in the form of an equation using loops. So what you want to do is you want to, you have your first example, x equals 5, 6, 7, 8, 1. What we want at the end of this loop is we want to output 5 plus 6 plus 7 plus 8 plus 1 is equal to 27. So at the end of your loop, we want this printed out here. Note the left-hand side of the answer must be dynamic. So you need to make sure that that these are dynamic. You don't want to just hard code some code in there that just says 5 plus 6 plus 7 plus 8 plus 1 equals 27. I want to be able to enter any number in here. So say I want to put in 1337 or something, then I'd want to see in the answer here 1 plus 3 plus 3 plus 7 equals what does that come out to? 14. Yeah. So make sure that this output here is dynamic. Don't just hard code these numbers in there. And then for the third question in the assignment, modify the program that you have written in question 1 to capture the below scenarios. If there is a 2 in the entered number, then do not add the 2. So in this case, we have x equals 7, 3, 2, 5, 1. The answer that we want outputted is 7 plus 3 plus 5 plus 1. Notice there's no 2 in here, and then we get 16 as the answer there. But then, and then for our second scenario, if there's a 9 in the entered number, then multiply it by 2 and add it. So for example, we have x equal to 1, 2, 9, 4, 9. So in this case, we want to have 1 plus 2 plus 18 because we multiply the 9 by 2 plus 4 plus 18, again, multiplying the 9 by 2, and then we get 43. So notice how I multiplied the 9 with 2 times because there are 2 9s. So we don't just want you to multiply just the first instance of 9. I want you to multiply both instances of 9 in that particular case. So any questions on the assignment here? Just a heads up, I kind of dropped a little hint about how to accomplish this assignment earlier on for how you might iterate over a number, because numbers, yeah, so just check out the beginning of the lecture where I talk about ways to iterate over a number here. All right, so as a demo at the end, let me open up PyCharm. Any questions on the assignment at all? Let's see. All right, let me just open up a new file here. Okay. Okay, cool. So let's see, there were a few things I wanted to cover here. The importance of making sure that your loop will exit. So say I have a while loop here, and I say like while x is, okay, so say we start out, we have x is equal to 0. Let's just say there. Then we have while x is greater than or equal to 0, print x, and then say I had x plus equals 1. So the problem here is that this will never evaluate to true, or never evaluate to false. It starts out as true because x is 0, and so x is greater than or equal to 0 because it is 0, and we're going to print x at 0. Then we're going to increment x using the plus equals operator. So now x is 1. And you'll notice here, no matter what I do, this is always going to end up true. So this while loop will execute forever if I let it. So if I run this here, just watch what happens. We're already up to very high numbers. It's just going to keep going as long as I let it. I'm going to stop that here. So had to stop it because this would have just executed forever and ever and ever. And it would have eventually, if I let it run for too long, it could have, caused issues for my computer because it was doing this so many times. So look, in that short amount of time, that very short amount of time that I let it run, we got 2,418,030 executions of that loop. So this is why it's very important to make sure that you end up with a situation where you can actually exit the loop, because in this case, this is never going to exit. What I could do here is I could then say I wanted it to exit after x equals 10. I could have if x equals 10, break. Remember, our break statement breaks us out of the loop, and I'm just going to move this plus equals to after the iteration here, because say I want it to output 10 still. Cool. So now if I run this, we just get 0 through 10 because it starts out at 0, prints 0, increments, and I broke out. I basically broke at 10. So something you might notice here is there's not much of a point in this situation here because this is always going to be true. So what I could instead do here is I could just have while true, because it's essentially the same thing based on the contents of my while loop here, and the value and the initial value of x. This while true is essentially equal to this while x is greater than or equal to 0, because it's always going to be true anyway. So we'll get the same exact output if I do this here. Just again, be very careful with while true, because while true will just will indefinitely execute your loop, basically. But this is a great way to make sure that your loop executes at least once. So say we have a condition in here. So say we started out with -1. If we started out with -1, sorry, let me just go back here. So if we start out with -1 here, and I run this program, nothing's going to happen, right? Because yeah, just nothing outputs here because x is not greater than or equal to 0. It's -1. So we want to make sure that this executes at least once. So say it's even -2. Again, nothing's going to execute here because we don't execute the loop at all. Then we can have while true in this particular case. Then instead of relying on that Boolean expression, we're now relying on this if statement here. So say we wanted it to break when x is equal to 0. Then we can run this here. And we start out -1, -2, -1, 0, and then we break out of the loop on that next iteration. So this is one way that you can, make sure that your code executes at least once. So say, in this particular case, we have, if say we wanted to put that same condition that we previously had there. So if x is greater than or equal to 0, break. So now we only want it to break once we hit the condition that was in there, or something like that. Then we can run that, and we'll still get -2, -1, 0. Yeah. Any questions on that? Or say we instead had this as less than or equal to 0. So it should break just immediately, right? Then we would run this here. We only get -2 because we just print -2 there, but then -2 is less than or equal to 0. We break. We make sure the code executes at least once. And so in this particular case, we want to make sure it executes at least once. So we have while true, and then we print that out, and then we have our if statement here to break us out of the loop to make sure that this while true doesn't execute infinitely. Okay, let me see. There were a couple things on the assignment that I did, or on the slides that I wanted to review. So is there anything that anyone wants to see specifically here? Oh, I know what I want to show. So I'm going to create a dictionary here. My dict equals, so say we have, let's give this an informative name. So we're going to call my dictionary favorite color dict. So David blue, John red, oops, Julie orange, Jill, let's go with brown. So in this particular case, say we want to iterate over our dictionary. So say we want to do the keys. So for key in favorite color dict dot keys, then I want to just print out the key here. So this is how we can just get the keys of the dictionary. So we get David, John, Julie, and Jill because those are just the keys there. Say we wanted to do values, so we could change this to value. Again, this doesn't matter. So say I leave that as keys, as key. It's kind of misleading, but just wanted to show you that the value you put here, it's not necessarily important. It's a little misleading in this particular case because I'm saying keys, but I'm actually getting the values from my dictionary. But just for the purpose of demonstration, this is really just a reference to the current item that you're iterating over. So in this particular case, we put in blue, red, orange, and brown. Let's make that so it makes a little more sense and just make it value so that for the purpose of demonstration and hopefully reducing a little confusion that might have happened from that demonstration. So for value and values. Something that's really helpful to do here is items. So if we do items, I'm just going to leave it here, let's just refactor this to item. So, so we have for item in favorite color dict.items, print the item. So if I run this, we're going to see tuples. So we have our tuple, David blue, John red, Julie orange, Jill brown, because this is basically the favorite color dict.items returns a list of tuples. The list of tuples has the key first and then the value. So we just output that list of tuples. Say, though, we wanted to actually reference each of those individual items using their key value pairs. We can do key comma value in favorite color dict, and then maybe we want to print here. So key, favorite color. So we have keys favorite color is, and then we do value. So using this comma here, basically what it's saying is like separate out this tuple into the variables key and value. So since key is always first and value is always second, this will be the key for the item. And then this will be the value for the item. And then we run this. And we have David's favorite color is blue, John's favorite color is red, Julie's favorite color is orange, Jill's favorite color is brown. So this is extremely useful for iterating over dictionaries when you want to have like different references in this particular case here. Yeah, so that's something I really wanted to go over here. What else can I demo? I want this to be as beneficial for you all as possible. So please, if there's anything that I can demo, do let me know. All right. So the hint that I do want to give a little bit of a hint for the assignment, something that you'll see here. So say I want to for num in 1, 2, 3, 4, 5, print num. This is going to give me an error, just a heads up for the assignment. Yeah, int object is not iterable. So ints aren't iterable, but what is iterable is a string. So say we have my num is equal to this value. So for num in my num, again, this is going to cause an error. So I'm going to run this again. So int object is not iterable. But what we can do here is we can cast this to a string, and then we can iterate over it, because remember, strings are an iterable object. So now we have 1, 2, 3, 4, 5. So hint for the assignment. You're going to need to use this concept here of casting to a string before you iterate over it. Just keep in mind, you know, if I now did, say I have total and set that equal to an empty, or set that equal to just some value here. Let me think. Okay, well, so if I set it equal to 0 to start out here, and then I try to do print total plus num, gonna get an error here. Unsupported operand types for plus. I'm trying to add total, which is an int, to num, which in this case is a string, because you know I've parsed this into a string and I'm iterating over each character in there. So we're gonna get an issue there. I don't want to give away too much for the assignment, so I'm gonna let you kind of figure this one out on your own. But some hints here for how to go about completing the assignment, and definitely reach out if you have any questions. Is there anything more I can demo on this? Loops are quite complicated, so please don't be shy. I'm sure if you have a question, most other people have it as well. All right. So if there are no questions, I will send out the assignment after class. Basically, what I want you to do is basically write the code, kind of like last week's assignment. Write the code that would solve these use cases and send that back to me in whatever format works well for you. Cool. And thank you again. Huge thank you again to Gaurav for taking the time to write the slides and the assignment for this week. Helps me out a lot. Just want to give him credit where credit is due. But please provide any feedback you might have on what you thought of the slides this week, as well as the assignment. I would also like feedback on the assignment from last week as well. One of you did give me some pretty good feedback there, which I found really helpful. I want this to be as effective as possible for the students in the class. We're doing this for you. So if something isn't working right, or if it works better for you, I want to know so that I can make sure that I create lectures and assignments that work well for the students in this class. All right, so I'm gonna go ahead and stop sharing my screen, and then we're gonna go over the solutions I was expecting for the assignment last week, as well as I want to show an example of an assignment from 2 weeks ago that where someone actually used a for loop to solve the assignment. But anyway, thank you so much, everybody, for joining today. I'm going to go ahead and stop recording, and then I'm going to show some demos at the end, unless there's any questions.
Thank you so much, David, for the lecture.
Say that again, sorry.
Thank you so much, David, for the lecture.
Of course, happy to do it. All right, I'm gonna stop recording, and then we'll go over the assignment from last week.